So as we all know that the problem of mutual exclusion is going to be arised frequently in the distributed system, and whenever the concurrent access of the shared resources uh, is done by the several users, or you can say by the several sites. So the solution of this problem is that whatever resources are available in the form of a shared resources, so they should be accessed at a time only by the one site. So that is why uh, the fundamental issues which is related to the mutual exclusion uh, uh, of the distributed system. So it means the distributed system should be designed in such a manner so that it can take care of all these things. So the first category of mutual exclusion algorithm, is the token-based algorithm. In token-based algorithm, unique token is being shared among the sites. Suppose we have 5-6 sites, and some site is executing its critical section. So meaning thereby the site which is executing its critical section must have the token. So if that is possessing the token, so the rest of the sites want to go into its critical section or in the critical region, they will broadcast the message that they are in the form of a request that they are in need of the mutual exclusion. They want a need to go into the critical section. So a site is allowed to enter its critical section if it possesses the token. Otherwise, it is not allowed to go into the critical section. Now, as far as the token-based algorithms are concerned, there are two important aspects. One aspect is that in this kind of algorithm, that every site will be using a certain sequence number, and that sequence number is being updated by the site itself whenever it is making any kind of the request asking for the token, because it wants to go into its critical section. So suppose a particular site is making a request first time, so the sequence number will be 1. If it is making the request second time, so the sequence number will be 2, and then 3, and then 4. The idea of having this sequence number is just to identify the outdated request or the current request. And the second is aspect as far as the token based algorithm is concerned is that whenever a particular site is having whenever a site is having the token, no other sites are allowed to go into its critical section until unless the site which is having the token exits from its critical section. So once a token has been issued to a particular site, it will go into its critical section, executes whatever it wants, and when the execution of that part for which it has requested is over, then only it allows to uh, give the token to the other requesting sites. So in the token based algorithm, we have the first algorithm is known as Suzuki Kasami algorithm. And in this Suzuki Kasami algorithm, if you go with the algorithm, you may feel a little bit confused. You will be a little bit confused by going through the concepts as well as, but I'm trying to make it clear right now that every site who is working in the distributed system maintains 4 things. 4 entities are being maintained. One entity is it is called the array, request array, which is being maintained by every site, and that array will be having the number of elements which will be representing the sequence number of the requesting sites. The second entity which is being maintained is the token array. Token array is a kind of array which is being maintained by the sites whenever it is going to issue token to the others. The third one is the queue, which third entity is the queue, which is being maintained by the site itself. The queue, the purpose of this queue is to keep highest priority sites first, because if it may be possible that a particular site is executing its critical section, and at the same time 3 more sites requests for the critical section to go into the critical section. So what that particular site will do, it will, since it is in its critical section, so what it will maintain a queue of what? Queue of the request which it has received from the many sites. And those site who has requested first will be in the top list, and the rest depending upon the time when they have requested. And the fourth entity which is being used, which is being maintained by the site, is to use this RNI. That is, the requesting site is going to the executing site is going to maintain another value that is known as request delay, meaning thereby by maintaining that, it will try to find that whether the request which is coming is the current request or it is the outdated request. Suppose site 1, what is the, I'm trying to explain what is the meaning of outdated request and the current request. Suppose site number 1 has made 4 requests, 1, 2, 3, and 4. So, and this way it is going to increment its sequence number. Site 3 is currently in the having the token, and site 1 has requested site 3 with its sequence number. Suppose the site 3, which is having the token, receives the request message which is having the sequence number 3, and granted the permission to deliver the token to the site number 1 on the request of the sequence number 3. And after that, again site 3 receives a request 2 from the site 1. So that request, which was generated earlier, but due to certain reasons it has not reached to the particular site, so it is being rejected. Why it is rejected? Because it is an outdated, because the third sequence number is already entertained by the site number 3, and the second sequence number request is coming later on, so it is going to reject it. So in this way, the Suzuki Kasami algorithm used to work. So before I'm going to explain this concept, I'm going to explain this algorithm with the help of an example. It will be more clear if you go through the example and then try to learn what is the algorithm. So first of all, there are, in this case, there are 4 sites, P1, P2, P3, and P4. All the sites, as I told you, maintains an array, that is the request array. Since all the sites are in ideal position, so all the sites are maintaining 0, 0, 0, 0, and in the form of R stands for the request array. And currently, suppose P2 is having the token, so token, and since it is not working, it is in the ideal state, so the token value is also 0, 0, 0. And nobody has made any kind of request, so Q is also an empty. So this is the initial state of the distributed system, which is having 4 processes, 4 sites, P1, P2, P3, P4, and everybody is in ideal state, so they maintain like this. So what happens when there is any request coming from a site to the site which is already having the token? So what happens? Now suppose P1 has made request. Now Suzuki Kasami algorithm is based on broadcasting. So you will see that suppose P1 has made a request. Suppose P1 has made a request, so it will broadcast a request message to P4, to P3, and to P2. Now P2 is having the token, so it is the P2 who will be uh, the main functional part of granting the token, because the token is lying with P2. So what it will happen? What will happen? Whenever it has made a request, P1 has made a request, so its request value will become 1. Now we have seen 4 vectors in this particular array. The first vector belongs to P1, second vector belongs to P2, third vector belongs to P3, and fourth vector belongs to P4. So that is why it has maintained 4. 4 values are in the array. So the first important thing which the P2 has to do is to check for the outdated request. Whether the request which has come from P1 to P2, whether it is outdated request or it is the current request which has to be entertained. So P1 has made a request in the form of a request IN, where I stands for P1, means I is 1. And since this P1 has made its first request, so it has sent a message request 11, where the first one represents P1 and second entity represents that it is the first request from the P1. So what the P2 will do, it will check for the outdated request. And how it will check the outdated request? By checking a condition that if RD2 is the request array which is maintained by process P2, site P2, with its first value here it is 1. So RD2 means RD2 means the request vector which is maintained by process P2. 2 stands for P2, RD means request, and 1 stands for the first component of this vector. Since this value is 0 and received request has n is equal to 1, this n is equal to 1. So since the value of n is greater than RD21, so request will be granted. And if this request value is more than 1, then this request which has been received by the P2 from P1 will not be granted. So it means it all depends upon the sequence number n and comparing with the first component of the process P2, that what is that value. If this is less with the request sequence number, then it will be granted. So the first thing is to check for the outdated request. So when this P2 assumes that now it's okay, the request can be granted, then what will happen? So every P1, P2, P3, P4, since it has issued a request in the form of a request 11, and so this request will be coming to this request will be coming to this request will be coming to this. So everyone will be updating its vector. So R1 first component will become 1 because P1 has requested. R1, sorry, this is R2, I think. This is R2. This is not R1. This is R2. So it will also update it 1. R3 will also update it as 1, and R4 will also update it for 1. Then it will check for the second condition. The token will be issued. Now permission is granted, but token is still not issued. For issuing the token, it has to check the second condition. And the second condition says that R should be equal to T plus 1. Now here, the current value of the first component of the token is 0, and the current value of the first component of R2 is 1. So R is equal to 1 and T is equal to 0 plus 1. So it means this equation is going to satisfy. And if this is so, if this is going to be true, so the token can be issued to the requester side. So before it is going to issue the token to the requesting side, it will check first the condition of the outdated request, and then it will check the second condition, whether the value of R, which is maintained by this vector which is holding the token, is equal to T plus 1 or not. If it is so, it will issue the token. So once it will issue the token, what will happen? There will be certain changes. So it has Now, the site which is having the token has been represented by a dot. So this is a red dot. It means it is currently having the token. Now, since it has to issue the token to the process P1, so this dot will be shifted over here. Now, this dot has been shifted over here. So when this dot is shifted over here, so what will it will also send two more things. One is the token vector as well as the queue. Since in this particular case, since queue was empty and only one process has requested, so queue is still empty. So whenever it will go into the next section, the t will be equal to 0, 0. The same token value, token vector, whatever is being maintained by P2, it will go as it is to the P1 and queue as empty. And this is already updated. Now, once this token is received by P1, it will enter into its critical region for executing its critical section. So it will take its own time till this process, this site is received, has received the token. So it will go into the critical section. Whenever it will go into the critical section, no other site will go into the critical section because they don't have the token. Since the token is with P1, so P1 is allowed to go into the for the exit to go into the critical section. Once it finished its task of the critical section, then it increments the first vector, first entity of the token vector from 0 to 1. That is what has been, it increments t as 1, 0, 0, 0, meaning till it not update t, it means the process is still in the critical area. Once it is going to execute and try to exit from its critical section, then only the token value, the first entity of the token value will be incremented. Otherwise, it will remain 0, 0, 0, 0, 0. So this will indicate that if the token is not updated, token value is not updated, it means that the process which has received the token is still in its critical section and no other. So it will update this token value from 0, 0, 0, 0 to 1, 0, 0, 0. So what will happen next? So what will happen? R1, R2, R3, and R4 will be like this, and T1, T will be 1, 0, 0, and still it is empty. Now this is the fourth situation. Now process, suppose process P3, this P3 site and P4 site request for critical section, and P3 is received first. So P1, what will P1 do? P1 checks the first condition. What is the first condition? The first condition is this one. And then if it is true, request vector maintained by the sites will be updated. R3, P3 and P4 has made the request. So if P3 and P4 has made the request and it is not in the critical region, it is exited from the critical region, and the first condition is going to be true. Now, R3 has made a request. So what will happen? It will send a request R3 request 3 1, and this component will be 1. R4 has made the request, so it will be R bracket mein 4 1. So both have made the request, and third component is still 0 here. Fourth component is still 0 here. It means if it has become 1 and 1, so it is going to accept. It is going to grant. Request is accepted. And once the request is accepted, what will be the position? All processes will update. One more thing. Whenever P3 and P4 is going to make a request, it will broadcast the message. P3 will broadcast the message to P4, P1, and P2. P4 will broadcast the message to P1, P2, and P3 in the form of a request. So what will happen? This will be updated because P3 and P4 has made a request. So this is become 1, and this become 1, this become 1, and this become 1, and this will also become 1, 1. Here something has been some wrong entries are there. This will also become 1 and 1. And since it has been exited from its critical section, so the first vector becomes 1, and it will maintain a queue now. Uh, the, uh, the order in which the request has been received, first for P3 has sent the request measure, then P4, then it will maintain a queue like this, P3, P4. Now the second condition is also going to be checked, then only the token will be granted. And the second condition is, R is equal to T plus 1. Now, if R is equal to, whether R is equal to T plus 1, now here the third component of T is 0, and here the third component of R is 1. So it is going to be true. Similarly, here the fourth component of T is equal to 0, and the fourth component of R is going to become 1. So both the conditions are true for both the processes, both the sites. So what will happen, since P3 has in the top of the queue, so P1 will grant the token, issue the token to the P3, since because the P3 has requested first. Now, and the queue which is showing P3, P4, this queue will also come along with this token value to the P3, but this P3 will be removed from this set because P1 has granted the permission to P3. So what will happen? T as it is will be coming to P3, Q as it is will be coming to here, and this token will be granted to P3. So what will happen? See, P3 has received the token, and token value will remain as it is. It will not be updated. And when it will be updated, it will be updated when it goes into the critical section and exits from its critical section, then only this value will be incremented and the Q will be equal to P4 only. So now P3 has received it. So P3 will go into its critical section, and whenever it goes into the critical section, it will, and when it exits itself from its critical section, when it exits from its critical section, this this token, third component of this token will be incremented by 1, and Q will be equal to 4. So once it exits from its critical section, token value will be incremented, and it will look for the Q value. So since in the queue it is already there that P4 is still in the waiting, so what it will do, it will allow P4, it will grant this token to the P4. For that, P4 has not to make request because it is already in the token. So token, whenever it is being issued, it is going to be issued with two entities. One is token vector and another is the queue set. Now, since P4 is in queue and it is pending, so token will be granted from P3 to P4, and in the same way, it does rest of the processes. So what will happen whenever this token is being received? So what will happen? This P4 will be coming over here. Let me change it also. So token value will remain same and the Q will become empty. Now, P4 was pending, so it is granted. Now it can go into its critical section and execute. So in this way, Suzuki Kasami algorithm executes. Now, at this particular situation, suppose now P1 is going to make another request, and this is in its critical section. If P1 is going to make a request, it will send a request in the form R1 R1 dot comma 2, because it is now the second request which is being sent by P1. So P1 will broadcast the second request to P4, P3, and P2, and it will be the P4 who will be taking care of that. So it will not allow to give the token until unless it is not going to exit from its critical section. And whenever P4 is going to exit from its critical section, this value will become 1. This value will become 1 when it is exiting. And then when P1 has made a request, since P1 has made a request, so what it will do, the P1, if P1 has made another request, so this will become 2. This also becomes 2, because the request is granted because it has already checked the condition. I'm not going to check the condition every time. I have done it once, so you are able to know. Now it becomes 2. And then this token value and the queue empty will be going to the issue to the P2, and this token will move to the P1. So in this way, Suzuki Kasami algorithm used to work. Now let me come to the concept. It may be possible now the things will be more clear. So if the site without a token needs to enter into the critical section, it will broadcast a request message for the token to all other sites that I have explained. What is token? Token maintains two things. One is queue of the request sites as well as an array such as ln. Here it has been shown in the form of a ln. I have shown in the example in the form of a t. No problem. So 1 to n, the sequence number of the most recent execution by the site J. Now, token holder sends the token to the requester if it is not inside the critical section. If it is in the inside of the critical section, it is not going to send the token until unless it is going to exit from its critical section. Token holder can make multiple accesses in the critical section, because if a site is having a token, so it can execute multiple critical sections. Now, as far as the design issues are concerned, that the first, the two things which it has to check for accepting the request, the outdated request, as well as the value of the token is less than the requesting sequence number or not. So that is the first one is distinguishing the outdated request message, and it is how it is being done. Request IN, where the ith site making the request, and each site is maintaining the request vector. So whatever is the largest sequence of the number which has requested by the J. Determine which site has an outstanding token request. ऐसा तो नहीं किसी और site के पास outstanding token request हो. So for that, here it has been shown that ln is equal to rn minus 1. In the example, I have shown that r should be equal to t plus 1. So both are same. So these are the two design issues. The third one is how it passes the token after finishing the critical section. Assume that a particular site is having the token, so this is equal to this one. So the token which consists of the q as well as the t, ln is, can you consider as a t, a q, where q is the queue of the requesting site. So the token holder checks this value, that t r is equal to t plus 1. If so, it places j into the queue. If it is so, and then it sends the token to the site which is having the top value, top entity, top site name in the queue. And so this is also the same explanation, that requesting site is going to increment its sequence number and sends the request in the form of a request I and the sequence number message to all the sites, where SN is the updated value of the request. After receiving the message from a particular site, it sets its request to the maximum value of the requesting as a request sequence number and the value which it has maintained. So whatsoever it is going to update it. And then once it is granted, it is going to execute its critical section. And the releasing of the critical section, after the critical section is over, once the token has been granted to a particular site and it has gone into the critical section, once it is going to over, then only the elements of the token will be updated. So in this way, this Suzuki Kasami algorithm used to work.